Now we're going to progress, okay? Now, I would still probably typically do this at the inception, even if I'm going to move into a lift with this component, because it gives me an initial capture on this to help reduce the likelihood of this shifting while we have guys in much more hazardous positions around this load putting in struts, okay? If we're going to lift, we're going to talk about strut lifts, we're going to talk about airbag lifts, but you can see very quickly with this application, short of trying to lift off of the firewall under here, the airbag applications are really, really limited, okay? So most of the time, this is going to be one of two types of lifts. Either a high directional anchor lift, where we rig up a bipod up above this load, capture it, and either use the bipod as a gantry or lift directly through a fixed bipod using a hauling system, a grip hoist, a chain hoist, any type of cable system. Or we're going to lift from the ground using struts. Today we're going to use hydrofusions. When we put in these struts, we want to have a strong awareness of the angle relationship between the struts and the load. So just like some of the side vehicle stabilization components we've done, we want to make sure that we're in that roughly 45 to 60 degree range, okay? It's important that you think about load that's being applied to the struts when you're doing true lifts. So as a general rule of thumb, from just an engineering perspective, at 45 degrees, whatever load is being assumed vertically, I am transferring that load at 1.5 times that load laterally. That plays a big role with commercial vehicles or heavier vehicles when we start thinking about our anchoring materials, our ratchet straps, our chains, our connectors that go from base plate to base plate or base plate to independent anchor. So to kind of put meat and potatoes to that, if this was theoretically a 1,000 pound load that we lifted, what I would be transferring with a 45 degree relationship on that strut would be 1,500 pounds on those straps, okay? So we want to consider that. We also want to understand that the more vertical we make our struts, the less that lateral tension is, but also we start to lose lateral stability. So you're always trying to find that married balance between vertical lifting capacity, reduction on lateral tensioning elements, but also maintaining lateral stability. So here's how this all basically plays out. We want to throw struts to this vehicle as primary stabilizers. The primary function is vertical and lateral stabilization. Then we're going to put secondary struts in here that are lifting struts. We're going to put hydrofusion bases, under traveling struts. They're going to be the lifting components. Your lifting segments should be thrown in at about 55 to 60 degrees, okay? Your stabilizing struts should be thrown in at about 45 degrees. That's going to give us a good balanced marriage between stabilization, lifting capacity, and reduction on tensioning elements. Now, the other important thing we need to discuss is how do we anchor all this stuff? How do we take these bases and secure them so they don't shift, travel, move, and they're engineered well, right? I really believe in load triangles. So as we analyze this load, we want to understand that there is a pivot point and there is a lift point. We want to make sure that we secure the pivot point, we draw it in towards the bases to make a tight package, and we prevent it from kicking out. If we don't secure that pivot point, then when we go to lift, the whole thing can shift, all the struts can go with it, and things go downhill really, really quickly. So when we talk about a load triangle, what we're talking about doing is creating two bases with two struts that travel up to the load with a ratchet strap going from base plate to base plate. We're then going to take two additional ratchet straps. So we're going to go from each of those independent base plates up to the nose of the vehicle. When we draw those in from the pivot point on the undercarriage, that's what secures the travel or the pivot point of the vehicle to the bases, gives us a nice tight triangle package for lifting and stabilization. So we're going to get all that laid out. Remember those basic fundamentals. Look at your load, identify the pivot point and the lifting point. Do a quick load calculation if it's necessary, depending on what kind of struts you're using, to ensure that your struts measure up with what you're putting on them, okay? They got to have an appropriate design load for what you're doing to them. Stabilizing struts, lifting struts. Always be redundant in those applications to make sure that you're balancing things out if you can. If you've got enough resources, it's going to give you a much more secure, much more safe, and much more stable lift.